All right, here is one way to write a trig function in standard form for a graph. If it's given to you in this format, you might have to change it. It just kind of depends upon what you have for your b value. So for the b value, if it's anything aside from 1, what you're going to do is you're going to factor that b value out in order to rewrite it and rewrite it in this format. So we're going to make it instead look like this, where we have a times sine. I'm going to pull that b value out, and that's going to get me x minus h plus k. Okay, and we're going to talk about more about how to do this, but I just want you to kind of see that these are essentially the same thing. They're just written slightly differently. What b is always going to get us, remember we do 2 pi divided by b to get our period, the absolute value of b, I should say. We get our period length every single time by doing that. What h is going to get me is what we're going to be focusing on in this video, and that's going to be getting us what is called our phase shift. The phase shift is a horizontal shift, so moving your graph left and right. Previously, we did our vertical shift. We did that already, and so that's where you're just moving your graph up and down. And then a gets us whatever the absolute value of a is, our amplitude. So how high up and how far down we're going from our midline of our graph. Okay, so let's apply this information and see what we've got here. All right, so right here, I am given an equation, f of x equals sine, and then we've got parentheses, x minus pi over 4. So notice right here, this looks very similar to how our equation was written up above, up here. It's very similar to this first one. It also technically is very similar to the second one. The only thing is here is I don't have 2 sets of parentheses. If you notice, my b value here is 1. So anytime you have a 1 right here, you don't have to worry about factoring it out. But if that b value that you have right here is anything aside from 1, then you must factor it out. And I'll do an example like that in just a minute. So right here, I don't have to do anything with this. So let's go ahead and identify. I've got my a is 1, my b is 1. My phase shift, which is going to be that h value now, or also previously my c, is actually going to be pi over 4. It's not negative pi over 4, because if we notice and pay attention to the original equation has a subtraction sign in it, and so does this one. So that h value is always going to be whatever is the opposite sign of what you see right here. And then my k value is whatever comes at the end here, or d, depending upon which version you're looking at. That one's going to be 0. So my phase shift is whatever this value is right here, my h value. We just have to make sure, again, it's always whatever is the opposite sign of what you have in the equation right here. So since this says that my h value is positive pi over 4, that means that my phase shift, so my phase shift is going to be positive pi over 4, which means I'm moving to the right pi over 4. I'm taking the whole graph and I'm going to shift it to the right pi over 4. I'm also going to abbreviate phase shift as PS. Okay, so anytime you see PS written, that's what that is. So I have my equation right here. I have my phase shift, which is pi over 4, and I'm moving to the right. So it's positive pi over 4. And then my period. My period is always going to be whatever 2 pi is divided by whatever your b value is. So I have 2 pi divided by b, which here is 1. So I didn't change my period at all. It's still just 2 pi. And that tells me how long the period, or how long the graph is going to go for before it starts to repeat itself. All right, so then now what we're going to do after we find our period, we have to figure out what a quarter of the period is. And the reason for that, if you think back, what we had before was we had these lines here. So we had 0 right here. Then we had pi over 2, pi, 3 pi over 2, and 2 pi. And each one of these between 0 and pi over 2 was a length of pi over 2. Between pi over 2 and pi was also pi over 2. Between pi and 3 pi over 2, it was also pi over 2. And between pi over 2 and 2 pi, it was also pi over 2. So this whole thing right here added up to the length of 2 pi. What I'm showing you is this whole thing is the length of the period, and between each marking here is 1/4 of that period. So what we're going to do is we're going to identify what 1/4 of that period actually is. And in this case, I mean, we just figured that one out. 1/4 of 2 pi is pi over 2. But let's go ahead and do the math for that just to make sure. So we're going to do 1/4. And that's how I'm going to label that. And we're always going to do whatever the period is. So PD, period, divided by 4. So in this case, we have 2 pi over 4, which reduces down to pi over 2. So that's what we've got for that. So now what we're going to do is we're going to label our x-axis according to our phase shift. We're no longer at 0, pi over 2, pi, 3 pi over 2, and 2 pi. We've shifted the whole graph. Instead of starting at 0, we're shifted it right so that we're starting at pi over 4 now instead. So I'm going to erase these because that's no longer where we're at anymore. We've shifted our whole graph. And so the phase shift, what this represents is this is the start of your graph now. My graph is no longer at 0. It's now actually at pi over 4. So I'm going to mark that first, pi over 4. All right, so now I've got to figure out the other 4 marks. So this whole thing from pi over 4 to this last mark is a total of 2 pi. So I'm going to go ahead and I'm just going to mark that right here so I can kind of have that little visual for myself. But this whole thing is 2 pi. And the reason I know that again is because that's the length of my period. My period is right here at 2 pi. So I'm going to figure out from there to here is pi over 2. And again, I've got pi over 2, another pi over 2, and another pi over 2. All of that adds up to 2 pi. So in order to figure out what I'm going to label this one down here as, I'm going to take that pi over 4 that I have right there, and I'm going to add pi over 2 to that. So let's try that. So if I have pi over 4, and I add pi over 2 to that. Remember, in order to add fractions, you have to have a common denominator. So I have 4 and 2. So what I'm going to do is I'm going to multiply this by 2, and I'm going to rewrite. So really what I have here is I have pi over 4 plus 2 pi over 4. When I add those together, I get 3 pi over 4. So that's what I'm going to label this next one as, 3 pi over 4. Now I'm going to take that 3 pi over 4, and I'm going to add 2 pi over 4 again to it. Notice, I'm not saying I'm going to add pi over 2, but pi over 2 and 2 pi over 4 are the same thing. I just wanted to add the thing that has the same common denominator. So when I add those together, that's going to get me 5 pi over 4. So that's what I'm going to put right here, 5 pi over 4. I'm going to add pi over 2 again. So I've got 5 pi over 4 plus 2 pi over 4 again. That gets me 7 pi over 4. So I've got 7 pi over 4. I'm going to add it one last time. And I'm going to change color here. I'm going to make it pink. All right. So now what I'm going to do here is I'm going to do 7 pi over 4, and I'm going to add 2 pi over 4 to that one again. And that gets me 9 pi over 4. So that's my last one, 9 pi over 4. Now, I'm going to double check, and this is a way to kind of catch some simple mistakes that you might make in adding up these fractions to get them. If you think about it, if this point right here is adding whatever my period length is, so 2 pi, to my initial starting point, what I'm going to do is I'm going to calculate out what my ending point would be. My ending point, and again, this is just to catch mistakes. We like to catch mistakes before we turn in a test, right? What I'm going to do is I'm going to take my phase shift and I'm going to add my period to it to make sure I get the same exact number. So for example, my phase shift in this case is pi over 4 and my period is 2 pi. So I'm going to add that to there. And again, I have to have a common denominator, so I'm going to put this over 4 and multiply by 4. So really I have pi over 4 plus 8 pi over 4, which gets me 9 pi over 4. So this period plus phase shift matches adding all of those up together. Since those match, these should also be correct. If these did not match, that's one way to catch a mistake when you're adding that quarter period to all of these. It is common to make mistakes there. So I highly, highly recommend doing that one last step just to kind of check yourself and catch some simple mistakes. Okay, so now we've labeled our x-axis. Now we have to label our y-axis. So the graph itself, we did not change our amplitude at all. So my amplitude still goes up to 1, and my minimum point is still -1. So this one down here would be -1. And then our midline is still 0 because we didn't have a vertical shift. So since we didn't shift up or down at all, we are just going to sit here and we're going to start here. So remember, sine goes up, down, up. So I'm going to start right here at the midline, except I'm no longer starting here on my x-axis. I've shifted the graph right. So I'm at pi over 4. And then at 3 pi over 4, I go up to 1. At 5 pi over 4, I'm back down to 0. At 7 pi over 4, I'm down at -1. And at 9 pi over 4, I'm back at 0. So what I'm going to do is I'm going to go ahead and draw my graph. And that should get me right here. If I go up, ooh, this is harder to do on this than I thought. I'm going to draw up here, down there, and up, back up. Okay, it's really hard to draw that on this little sketch pad, so I apologize. That looks like garbage. I'll get better, I promise. But you get the gist of it. You curve up, you come back down, and then you curve back up. All right, let's try another one. I'm going to go ahead and skip to this one because I like this one. It has a period change and a phase shift. So I've got a couple different things going on in here. So the first thing that I'm going to do is I'm going to go ahead, I need to rewrite this. Because if you notice right here, this 2, it's attached to the x. I can't have it attached to the x, so what I need to do is I need to factor that out. So what I need to do is first I've got f of x, and this equals sine, and what I'm pulling out is 2. So I'm going to divide this by 2. I'm also going to divide this by 2. So I've got to figure out what is pi over 3 divided by 2. So let's look at that. So if I do pi over 3 divided by 2, remember I've got a fraction divided by another number. So what I'm going to do is I'm going to do keep change flip. So I've got pi over 3 times 1/2. And that's going to get me pi over 6. So what I'm going to have here instead of pi over 3 is I'm going to have x plus pi over 6. So this is how my equation is going to look now. You could also rewrite this as sine. You don't necessarily have to have that set of parentheses. It's the same exact gist, okay? So those are the same thing. So now I can clearly see that my A value is 1, my B value is 2, that H value here, again, remember it's the opposite sign, it's negative pi over 6. My K value on the outside is 0. Remember, if it's not there, it's 0. All right, so let's look and see what we've got here. So the first thing that I need to do is I need to identify my phase shift. So my phase shift here, phase shift, is whatever that H value was. So here it's negative pi over 6. So that means that I'm taking my entire graph, and instead of going right pi over 6, I'm actually going left pi over 6. I've shifted this direction. Okay. All right, and now I've got to figure out what is the period of the graph. Well, it's definitely changed, so let's figure out what that is. So my period, PD. Remember, period is 2 pi over the absolute value of B. So here I have 2 pi divided by 2. So that gets me pi. So instead of having it repeat every 2 pi, it's now going to repeat every pi. So I've squished my graph. I've smushed it down closer together. And then we've got to figure out what the quarter of our graph is, the quarter of that period. So the quarter is going to be whatever that period is divided by 4. So in this case, it's pi over 4. So now remember, the phase shift, whatever you have for your phase shift, is your starting point. So this is negative pi over 6. Now notice, I'm to the left of my y-axis because this is a negative value. Whereas on the last one, I was to the right of the y-axis because I started at positive pi over 4. So now I'm having this right here, this negative pi over 6. That's exactly where I'm going to be starting. And now I've got to figure out what all my 4 little parts are that I've got to find now. Now, I'm not going to draw all the lines until I have exactly what their values are because I don't know if I'm going to be to the left or to the right of the y-axis just yet. So let's go ahead and figure this out. So if I start at negative pi over 6, I've got negative pi over 6, and I'm going to add that quarter period to that. Remember, I have to get a common denominator. So one common denominator for these two would be to multiply 4 by 3 and to multiply 6 by 2, and that's going to get me 12 for both of them. So what I've really got here is I have negative 2 pi over 12 plus 3 pi over 12. And now I can clearly see that when I add those together, that gets me pi over 12. So my first point is just to the right of the y-axis. So I'm going to go ahead and do that. And if you notice here, negative pi over 6 is a bigger fraction. Taking something and dividing it into 6 pieces gets me a bigger piece than dividing it into 12 pieces. So I put the pi over 12 closer to the y-axis. All right, so now what I'm going to do is I'm going to figure out what the next one is. I've got pi over 12. I'm going to add pi over 4 again. Remember, this is equivalent to pi over 4, so I'm just going to use that because that already gets me a common denominator. So 3 pi over 12. That gets me 4 pi over 12. I need to reduce it. So 4 pi over 12, that's going to reduce down, and that's going to get me pi over 3. All right, I'm going to take that same 4 pi over 12 because 4 pi over 12 is equal to pi over 3. And I'm going to add 3 pi over 12 again. And that gets me 7 pi over 12. So there's my next one. 7 pi over 12. I've got to get one last one, so I'm going to add 3 pi over 12 again. And that's going to get me 10 pi over 12, which reduces. I can reduce that down to 5 pi over 6. I'm not done. I want to make sure that I did this correctly, that I labeled my x-axis as correct as possible. So again, I'm going to take the period and I'm going to add that to my phase shift. So my phase shift was negative pi over 6. I'm going to add pi to that. So that's 6 over 6. Negative pi plus 6 gets me 5 pi, and then I have my 6. So 5 pi over 6 is 5 pi over 6 right here. So you see I've got that labeled correctly now. All right, so what I'm going to do now is I'm going to label my y-axis. All right, so I'm going to just make this spot right here 1, and I'm going to make this one negative 1, just for the sake of me trying to draw on the sketch pad. Okay, I didn't have an amplitude change, and I didn't have a vertical shift, so that's how come it's just 1 to negative 1. None of that changed. If I had a vertical shift or an amplitude change, then I would have to change my y-axis. Again, this is sine. It's also not negative in front of my sine, so I don't have to worry about flipping it at all. And so now I'm just going to graph it. So I start at negative pi over 6. At pi over 12, I'm up at 1. At pi over 3, I'm at negative 1. I'm sorry, not at negative 1. I'm at 0. I went too far. I'm at 0. At 7 pi over 12, I go to negative 1. And then at 5 pi over 6, I'm back to 0. So let's try and do this as a dash. See if that doesn't help me for tracing here. Okay, it's a little bit better. All right, so here's my graph. So as you can see, phase shift can make things really complicated. There's a lot going on. There's a lot of fractions involved, and you have to pay attention. And if you mess up on one, you're probably messing up on more than one. So we have to take our time, we have to be careful, and we have to pay attention.